Hi everyone, this is Miss Robson back again. We are Unit 9, Day 5, graphing exponential growth functions. So we are talking about exponential growth and decay. Day 5 is growth. Day 6 will be decay. All right, so let's talk about an exponential function. So some of these things should look a little familiar. We've got our h and we've got our k. That seems familiar. Remember, our h tells us to go left or right. Our k tells us whether we're going up or down. But if you notice, the h and the x are attached to the exponent. Hence, exponential functions. Let's do it. All right, in this situation, so the growth, decay, or factor is the b, okay, which is the base of our exponent. All right, so this b has the exponent attached. All right. This a, again, it goes with all your other functions. You've already learned about whether it's stretching or it is compressing or reflecting. That's our a. And then our asymptote. What? Our asymptote goes with our k. All right? So that tells us whether it's going up or down. If there is no k, y equals 0. Okay? Which means that our function doesn't cross that horizontal asymptote. All right, so now let's talk about, so I just wanted to have like a little picture for you guys just to talk about the different types, and then we can move on to our notes. So again, exponential growth, our b is greater than 1. It's getting bigger over time, okay, so then you can see that it's going up. An exponential decay, which we'll again talk about more on day 6. B is less than 1, so this doesn't have to do with the a, all right? It has to do with the b and the factor. If b is less than 1, it's a decay, it's getting smaller. So it's starting up high and then going down lower, okay? If you guys notice, it does not cross the 0 because that's our horizontal asymptote unless we have a k. All right, and then here's just another example of exponential functions. What does it mean for the left, right, up, or down? So again, my h tells me my horizontal shift. So like I said, left or right. My k tells me whether I'm going up or down. Okay, so for this situation, the x minus 4 would mean going right 4. And then this minus 1 would mean going down 1. So I just wanted to give you guys a little example. What would this 3 mean? Well, that 3 would mean that it was a stretch. So looking at a problem, you should already kind of have an idea of what this thing looks like. All right, so let's get into it. Let's stop the talking. All right, so I want to kind of remind you guys, well, what does 3 to the x mean? Okay, so I'm going to make a little chart. So if I had 3 to the 0, that would equal 1. Anything to the 0 power is 1. Why? Well, because 3 to the first power is 3. Well, how do I get from 1 to 3? I times it by 3. Okay, if this was 0, I wouldn't have a function because everything would be 0 after that. And then 3 to the second power is 9. Do you see how fast this thing rockets up? Okay, now let's go the other way. Well, what if I plugged in -1? If I plugged in for x -1, I would get 1/3 because I'm going to drop it down. 3 to the -2 would equal 1/9. So if you notice, when I am going up the factor, right? So when I plug in positive numbers, it goes up really, really fast. And when I plug in negative numbers, it gets smaller and smaller and smaller, closer and closer to 0. Okay, so that's the difference. All right, so for the HA, well, there is no K attached to this one. There's no plus or minus for this one. So my horizontal asymptote is 0. What is my domain? Well, that's all real numbers. And then my range is y is greater than 0. Okay, and we can again plot some points. So into your graphing calculator, you want to write y3 to the x power, okay? And that's how you can graph it in your graphing calculator. Please practice this so then you're used to it. So we have 3. So when I plug in, so let's plug in some points based on my chart. So if I plug in 0, I get 1. When I plug in 1, I get 3, 2, 3. And then when I plug in 3, I get 9, which is again way up there. When I plug in -1, I get 1/3. So -1, I'm going to get 1/3 and then 1/9, and then it's going to get closer and closer and closer to 0. But again, it's not going to cross it because my horizontal asymptote is at the 0. So if you notice, it starts off really low and then skyrockets. I would recommend to start off plugging in 0, get that first point, and then get a point on at least either side so you can see how fast it's going up. Okay? All right, so again, I've got my horizontal asymptote, y equals 0. My domain is all real numbers. X can be, you can plug in anything for X. There's no restrictions. The range, there's nothing lower than 0, and it doesn't equal 0. It's just y is greater than 0. And then let's get into this end behavior. Okay? So again, if you're trying to put this into your calculator, y equals 3 to the x power, and then you can go to your table by going to second graph, and it can show you your table. All right, end behavior. As x is approaching negative infinity, what is f of x doing? Well, f of x is approaching 0. Okay, because it's getting closer and closer to 0 on this side. When x is approaching infinity, so when it's getting bigger, what's happening to y? Well, y is also approaching infinity. Okay? All right, fantastic. So that's my parent function. So 3 to the x, b was 3. All right, let's try these two out. All right, so we don't have any a's for now. We just are dealing with our growth, all right? Our growth because it's greater than 1. All right, so 2 to the x. So let's plug in 2 points and see what happens. So I'm going to plug in 0. 2 to the 0 power is 1. I'm going to then plug in 1 to x. 2 to the first is 2. So let's plug in these 2 points. So 0, 1, and then 1 up 2. I know it's going up like this. And then again, it's tapering off on the left-hand side. Because when I plug in negative 1, I'm going to get 1/2 because I'm going to drop down. That base. Okay, so again, it's just going to get smaller and smaller. My domain is all real numbers. My range is y is greater than 0. Okay, so that's for this one. Again, I want to include my horizontal asymptote. It does not cross the 0. Okay, it just gets smaller and smaller. All right, the next one. So 4 to the x. So is it going to go up faster? Or is it going to go up slower? Well, 4 is bigger than 2, so it's going to go up faster. So again, we're going to start at 0, 1. When I plug in 0, I get 1. When I plug in 1, I get 4. So 1, 4. So let's see how much faster this thing goes up. So 0, 1, and then over 1 up. 1, 2, 3, 4. So it's even going up faster than the other one. Okay, and then it tapers off on this side. I have my horizontal asymptote, range is all real numbers. Domain is all real numbers, range is y is greater than 0. All right. Okay, now let's get into a little bit more complicated problems. So when we have number 3, so again, my A is 3, my B is 2. Please be careful when you're plugging these in. So if I'm going to plug in 0, and I'm going to plug in 1 to see what happens. Okay, so let's plug in 0. So I have 3 times 2 to the 0. Please be careful. You are putting that into the calculator first. Okay, so I have to do 2 to the 0, not the whole thing. So just the B, just the 2 is to the 0 power, which is 1. And then I have 3 times 1, which is 3. All right, so what happened, it shifted up to the 3, okay? So my A affected where I started my graph, okay? Now let's try it again. I'm going to do 3 times 2 to the first power. Again, only the 2 has the exponent, so be very careful when you put this in the calculator. So 2 to the first is 2, and 3 times 2 is 6. So when I plug in 1, my answer is 6. So let's try this. So 1, 2, 3. And then over 1 up. 1, 2, 3, 4, 5, 6. All right, so it shifted. It went up, and it's going to stretch because of the 3. Okay, so it just kind of looks different up here because of the stretch. All right, And again, if you're like, ooh, I don't know how the rest of this should look like, okay, well then plug in -1. It's all good. So when I plug in -1, I'm just going to put it down here, then 2 to the -1 is 1/2. And then I have 3 times 1/2, which is 3/2, or 1.5, so 3/2. So if I go over to the -1, I'm going to go up 1 and halfway there. So then I kind of see what this thing looks like. Okay. Again, the horizontal asymptote is 0. Because again, I don't have a K. I don't have a plus or minus there. So it's just stretching on how you, it's stretched based on that 3. All right, the domain, again, all real numbers. The range, did that change? No, it did not. It's still y is greater than 0. Okay. It just stretched. So you want to plug in a few points and see what this looks like. Or again, put it in your calculator. So you would have put 3 times 2 to the x. Okay. All right, number 4. How is this affected? So -2.5. So that's a reflection because it's a negative. And then the 0.25 is going to make it compress. So it's going to look different than the ones before. All right. So let's try some of these. So I'm going to plug in 0. I'm going to plug in 1. That's a good bet. So 4 to the 0 power is 1 times -2.5 is -0.25. Sorry, -0.25. There we go. Now let's plug in 1. I need to figure this out. So 4 to the first power is 4. Okay, so again, you can write it out if that helps you. So 4 to the first power. So 4 times -0.25. And then what would we get for that one? We would get -1. Okay, so based on the reflection, instead of it going up, we're going to have it slow, kind of curve this way. So I'm going to go 0, -0.25. So it's in between there. And then over 1 and then down -1. So we are going to kind of skate it by like this. And there we go. And you can plot more points if you like to, or put it in the table. Domain, still all real numbers. The x's, it covers all the x's. There's no restrictions. Range, how did range affect it? Well, the horizontal asymptote is still 0, but the graph is down here. So y is less than 0. Okay, instead of greater than. Alrighty. Okay. All right, now we have some different graphs based on the plus or minus. All right, so let's look at number 5. Okay, so the H is 3, the K is 1. So what does that mean? So that means I'm going right 3 and up 1. So how does that change it? Well, now my horizontal asymptote is 1. So here we go. I know that that's my horizontal. Okay. And now, what does this mean? Right 3, up 1. Okay, from here. So over 3, 1, 2, 3. And it says up 1, but we have this line right here. So let's plug in 3 and see what happens. So I have 2 to the 3 minus 3 plus 1. Okay, so I plugged in 3 for x to see what happens. Okay, so I have 3 minus 3, which is 0, so 2 to the 0 plus 1. Well, 2 to the 0 is 1. 1 plus 1 is 2. So I'm going to go over 3, 1, 2, 3, and up 2, 1, 2. So when it says right 3 and up 2, that is from the asymptote, okay? So over 3, up 1, okay? Right, because that plus 1 is kind of that barrier. All right, and then you again can plug in another point. So it shifted over 3. So instead of plugging in 0, I plugged in 3. Now let's plug in 4. So I have 2, 4 minus 3 plus 1. So I have 2 to the first plus 1. 2 plus 1 is 3. So I'm going to go over 4. 1, 2, 3, 4, up 3. 1, 2, 3. All right, so then again, it shifted over where I'm plugging in those points. And when you notice when you plot this, okay, again, be very careful. If you want to add parentheses, I would highly recommend it. So if you put this in the calculator, let me show you real quick. So I did 2. So I did 2 and then upside down V parentheses x minus 3 parentheses. And you see how I'm still up in that section. So I'm going to go to the right and then press +1. Okay, and then when I graph it, there's my graph. Then again, you notice it's kind of skating over right above the 1 second table. And you can see those points. So if you notice, it just gets smaller and smaller and smaller. Okay, and your calculator can't figure out what to do after -11. It's just it's so close to 1. Okay, but again, it does not cross the 1. So all these numbers are just getting closer and closer to the 1. Why? Because of that +1, because of your K. All right, so again, just be very careful with your parentheses. All right, so the domain is, again, all real numbers. Your range is your horizontal asymptote. So y is greater than 1, okay? Or, sorry, y is greater than 1. I said it but didn't write it. Oh, my goodness. All right, and behavior. So as x is approaching -infinity, f of x is approaching what? Okay, well, it's approaching 1. When x is approaching infinity, f of x is approaching infinity. As x is getting bigger, what's happening to y? Y is getting bigger also. Okay, your range, you can also write, guys, you can write -infinity to 1 also if you prefer. And then domain, you can also write -infinity to infinity. Just ask your teacher what they prefer. Okay, all right, number 6, I want you guys to try this one out. So this is going to be left 1, down 3. Okay, so again, your horizontal asymptote 1, 2, 3 is going to be down at the -3. Okay, so it won't go past that point. I want you guys to try how to graph it and what this thing looks like. All right, so I put this in my calculator. So 4 to the x plus 1 minus 3. Again, whatever your h is, that's the number I plug back in. So 1, so I can plug that back in and kind of see what's going on. You can also graph it. You could also go second table and see some of the points so you can see, again, what this looks like. So -1, -2, 0, 1, and then it skyrockets to 113. So that's how fast it's stretching based on the base of 4. Okay, so 4 to the certain power made it skyrocket like that. And then if you notice, the further I go, oh my goodness, it's just getting closer and closer to 3. Again, -7 isn't actually -3. It's just your calculator can't go that many decimals, so it rounds up. Okay, so again, you know that it cannot cross that -3. All right, so how does that affect? Well, so again, it just skyrockets way fast, way up there very quickly. So I graphed a few points. So domain, again, is all real numbers. Range, okay, well, where can it not cross? The point of no return is -3. So y is greater than -3. You can also write that -3 to infinity. Domain, you can also write -infinity to infinity. Okay, and behavior, well, what is happening? All right, so let's look at that. So again, plotting some points, you guys can plug those in and practice. Plugging in your calculator, practicing that way also. So x is -infinity. What's happening to f of x? Okay, well, as it's approaching here, y is approaching -3. Okay, as x is approaching infinity, what's happening to f of x? Well, that's approaching infinity because it's going up. Again, these are all growth examples. All right, we've got 2 more, guys. So I want you guys to try number 7. What I would recommend, again, this means x plus 2 means left 2, and this means down 1. So I know my range has to do with this k. So y has to be greater than -1. That's how I know where my horizontal asymptote is. All right. I would recommend whatever your h is, that's the number I'd plug back in. Okay. That's kind of a good starting point to see what's happening. So 2 plus 2 is 4. 3 to the 4th, see what's going on with that, times 2 minus 1, that's kind of a big number. So you kind of want to, you're going to have to kind of play around with what kind of points you have when plotting them. You might want to plug in 0, you might want to plug in 1, get a few points down to kind of see what this thing looks like. So this is what I got for my graph. So I found some points and I said, okay, well, which one of these are pretty doable in graphing? Well, I can graph these two and then kind of show that it's skyrocketing pretty fast. If you notice, if a normal parent function starts here, right, it usually starts at 0. Okay, it usually starts at 0, 1, right? Well, it said left 2 and down 1. So left 2 and down 1. And then because of this stretch, okay, it kind of stretched out that way. So just kind of give yourself an idea of what your graph should look like before you get started. Okay, what on earth is going to happen if I have a negative x? All right, so let's think about this. When I'm plugging in 0, when I plug in 1, when I plug in -1, how does that affect it? All right, here's our last one. All right, sorry, domain, all real numbers, y is greater than -1. Okay, so how would we do this? We're going to plug in some points and kind of see what happens, and then we can plug in our horizontal asymptote and graph this thing. Okay, so let's plug in 0. So 2 to the 0 power is 1, okay, and then 1 plus 2 is 3. So 0, 3. So 1, 2, 3. All right, there we go. So, it usually starts off here and it went up 2 because of this plus 2, guys. All right, now let's plug in 1. So 2 to the -1 plus 2. Well, this would be 1/2 plus 2. Okay, so 0.5 plus 2, so we'd get 5/2 or 2.5. So over 1 and then up 1, 2, and then 0.5. It's going this way instead of this way because of that negative x. All right, now let's try plugging in -1. So I have 2 to the -1 plus 2. Well, those two negatives would make a positive. So I'd have 2 to the first power plus 2. 2 plus 2 is 4. So I have -1 up 1, 2, 3, 4. So, and then I know my horizontal asymptote. Well, what is my k? Well, that's 2. So at the 2, I'm going to draw my horizontal asymptote. That's dashed line. So, and I know it's going to kind of skate right above that 2. So because of that negative x, this is actually a decay. Another way you could write it is 1 over 2 to the x plus 2. Okay? Because it's actually 1/2. All right? So that's why it's going this way instead of up that way. Okay? So it's starting off high and then dropping down. Well, does that affect the range? No, the range is still y is greater than 2. All my y values are above the 2. My domain is all real numbers still, or -∞ to infinity. What would it affect? It would affect my end behavior. So if x was approaching -∞, what's happening to the y? Well, the y, or the f of x, is approaching infinity. What happens when x is approaching infinity? Well, f of x is approaching the 2. Okay, it's getting closer and closer to 2. All right, so that's what a little bit of a difference is. So thanks for joining me, and have a great day.